All right, so Specialist Maths Units 3 and 4, Lecture 5. We're going to look at circles today. So we're going to look at the circle through the center and radius form. We're going to look at converting from center and radius form to the general form, and then some conditions for the circle's existence once we're in general form. And then we're going to look at shaded regions. So let's look at center and radius form first. Basically, this is just the form of a circle where we sort of get given the center and the radius. We see that it says x minus h squared plus y minus k squared equals r squared. What that means is the x position of the center point is at h and the y position of the center point is at k. And r is the radius. So if we start to change things around, we can see at the moment we've got a circle centered on the origin, 0, 0, because h is 0 and k is 0. And the radius is 4, as you can see. What we can do is we can start to change h. If we make h, say, positive 1, we can see that the center point now is at 1, 0. And similarly, if we change k, the center point's at 1, 2. Obviously, if we change k in the negative direction, it moves down. Change h, make h negative, it moves to the left. And obviously, if we change r, it gets bigger or it gets smaller. Remember, r squared, even if r is negative, we're squaring it, right? So we get this situation going on. So that should give you enough information to be able to sketch something that's in center and radius form. Now, you're probably wondering, how do you find all the sort of intercepts? But remember, to find x-intercepts, you let y equals 0. To find y-intercepts, let x equals 0, and then solve the equation. So that would tell you all the information you would need to know about that circle in space or in the Cartesian plane. Okay, so the next thing we're actually going to do is we're going to convert to general form. So again, we have center radius form here. If we just do some expansion, what we're going to get is this. So if we expand this out, we're going to get this. So this is a binomial. So we're going to get x squared minus 2xh plus h squared plus y squared minus 2yk plus k squared. And that still equals r squared. What we're going to do is we're just going to move this r squared to the other side. And I'm just going to put the x squared and the y squared together. So we get x squared and y squared together there. And then everything else stays the same. I'm actually going to do with these two terms here is I'm going to take negative 2h out as a factor. And similarly here, I'm going to take negative 2k out as a factor. And yeah, what we get is this sort of expression. For some reason, r is moved back over to the right, but that doesn't matter. What we're going to do is we're going to call negative 2hd. I'm going to call negative 2ke. And then all these other terms are just going to combine to be this term f. Again, this term f would be h squared plus k squared minus r squared. These are all just constant terms. And so what we can do now is we can actually complete the square on this, and we can learn some interesting facts about about the circle through doing this. We get x squared plus y squared plus dx minus ey plus f equals 0. That's not right. That should have been the same as the previous one. Just brought this over here for now. Okay, I've written the same thing again. All right, what we want to do is we want to complete the square on this now. So we're going to look at this first term. Remember, to complete the square, you half the middle value and you square it. Half of d squared, half of d all squared, I should say, is d squared on 4. But you can't just randomly add a d squared on 4. You have to subtract d squared on 4. So it's sort of just completing the square on these first two terms here. And then you complete the square on these second two terms. You get y squared plus ey plus e squared on 4. Again, subtracting e squared on 4. Don't forget to add f, and all of that equals 0. Okay. Adding d squared on 4 and e squared on 4 to the right-hand side, and then subtracting f, we get this. And then finally, we just get common denominators here for this right-hand side. So we write minus 4f on 4 and then sort of put it all as one fraction. You'll see that the right-hand side is d squared plus e squared minus 4f on 4. But we know, just looking at this now, looking at this and comparing it to this first point, we know that this thing on the right-hand side must be equal to r squared. Okay, and similarly, h must be d on 2, and k must be e on 2. In any case, the thing we're interested in is this right-hand side being r squared, and we know that r squared has to be greater than or equal to 0 because it's the radius of a circle. So what that means is this thing on the right-hand side has to be greater than or equal to 0. And so, yeah, what we get is an interesting situation where if we come over here, we can actually explore that a little bit more. Again, all the same things here. At the moment, D is 2, E is 2, and F is 2. And that corresponds to a point in space. So that is just the point, in this case, -1, 1. But if we change things, if we make if we make this expression negative, then the whole thing disappears, right? There is no circle. But if we make it positive, we get a circle sort of existing in the Cartesian plane. So it's important, obviously, what d squared plus e squared minus 4f is equal to. Again, if it's equal to 0, then it's just a point in space. If it's less than 0, rather, it's less than 0, then the circle doesn't exist. And if it's more than 0, the circle does exist. So, and then obviously this does some sort of different transformations. Don't need to worry too much about that. But as long as that expression is greater than 0, then you have a circle in space. So I think that's pretty interesting. Okay, the last thing I wanted to look at is shaded regions. So what we're going to do is we're going to shade the region where we have x squared plus y squared being less than 16 and x is less than or equal to -2. So if we just look at this first part here, let's just consider x squared plus y squared equals 16. If we were to draw that, that's sort of in center radius form. It's centered on the origin and the radius is 4 because r squared is 16. And you notice it's in a dashed line here because we can't include 16. So anywhere inside this circle will have a value where x squared plus y squared is less than 16 but not equal to 16. Okay, so that's sort of, if we were to shade this region in, that would be this region, x squared plus y squared less than 16. But we want that where it intersects with this region where x is less than or equal to -2. And so negative x being -2 is here. So we need it to be inside the circle, but less than -2. So I think you would agree that would be this region here. And this is sort of a solid line here because you can include -2. So that is how you shade the relevant region when you get given an inequality with a circle. So hopefully you're finding that useful. Let me know if you've got any questions and good luck. I'll talk to you soon.